A lot of us were taught math like it was just a bunch of random rules you had to memorize. But what if it's not random at all? What if there's a hidden grammar, a kind of secret rule book that, once you see it, makes everything just click? In this explainer, we're going to pull back the curtain and look at the simple, powerful logic that makes all of math work. So take a look at this. 3 times x plus 4 plus 2x. Yeah, it looks like a mess, doesn't it? It's just a jumble of letters, numbers, and parentheses. But what if I told you we could use that secret rulebook to turn this chaotic-looking puzzle into something clean, simple, and actually understandable? Let's give it a shot.
So, we're not just hunting for the final answer here. The real goal is to understand why the answer is what it is. We're about to crack open the rulebook and find the fundamental tools that let us confidently take apart expressions like this one and bring a little order to the chaos.
Okay, so what are these rules officially? They're called the properties of numbers, but hey, don't think of them as these rigid, boring laws. They're more like the fundamental grammar of math. Seriously, everything from basic algebra all the way up to complex calculus is built right on top of this foundation. All right, so first up, let's talk about how we can basically shuffle numbers around without completely breaking the mass. This all comes down to 2 key ideas about order and grouping, and I guarantee you use these every single day without even realizing it. Think about it like this. You're at the grocery store. You toss some apples in your cart, then you grab some bananas. Now, is your total any different than if you'd grabbed the bananas first? Of course not. The total is exactly the same no matter what order you put them in. That super simple idea, that's our first property. And that, right there, is the commutative property. It basically says that for addition and multiplication, you can commute, move the numbers around, and the result stays the same. So 4 plus 7 is the exact same thing as 7 plus 4. Simple, right? But trust me, it's incredibly powerful.
Okay, now what about grouping things? Let's say you're organizing a big project. If you combine Team A and Team B first, and then add in Team C, you get the same number of people as if you combined Team B and C first, and then added Team A, right? The way you group them up doesn't change the final head count at all.
And that is the core idea behind the associative property. It tells us that when we're only adding or only multiplying, we can move the parentheses, the groupings, around however we want, and the outcome won't change. We can associate the numbers differently. Okay, let's pause here, because this is where people get tripped up all the time. Let's make it super clear. Cumulative is all about changing the order of the numbers. Associative is all about changing the grouping with parentheses. Just think, commute means to move around, associate means to group up. That's the big difference. All right, let's switch gears and talk about 2 really, really special numbers, 0 and 1. They're not like the others. They have these unique powers that give us 2 more essential rules, the identity and inverse properties. This brings us to the identity properties, and their special power is, well, it's doing nothing. And that's actually a huge deal in math. If you add 0 to any number, it leaves its identity unchanged. Same thing if you multiply any number by 1. 0 and 1 are like the neutral, do-nothing elements of math. Now, what about the opposite of doing nothing? What about undoing something? Imagine you buy something for $20. Then you change your mind, return it, and get a $20 refund. What's the net effect on your wallet? 0, right? The 2 transactions perfectly canceled each other out. And this idea of canceling is key. And that's exactly what the inverse properties are all about. For any number A, its additive inverse is just negative A. Because when you add them together, you get back to our identity, 0. For multiplication, the inverse is its reciprocal, 1 divided by A. Because when you multiply them, you get back to our other identity, 1. They just undo each other. And hey, while we're on the subject of 0, we can't forget this one super simple but super important rule, the 0 property. Any number, I don't care how big it is, when you multiply it by 0, it just becomes 0. It's a simple idea, but it's a cornerstone for solving all kinds of equations. Okay, so if the other properties are like the screwdrivers and wrenches in our toolkit, this next one, this is the master key. The distributive property is what connects addition and multiplication, and it is absolutely 100% essential for algebra. So how does it work in practice? Well, to get rid of the parentheses here, you distribute the 4 to everything on the inside. First, you do 4 times 2. Boom, you get 8. Then you do 4 times y. That gives you 4y. Slap them together with a plus sign, and there you have it, 8 plus 4y. You've successfully broken open the expression. So here's the official rule. Basically, it just says that multiplying a number by a group in parentheses is the exact same thing as multiplying it by each piece of the group one by one and then adding all those results up. This property is our #1 tool for simplifying complicated-looking stuff.
All right, we've assembled our toolkit. We've got the commutative, associative, identity, inverse, and that master key, the distributive property. Now, it's time. Let's go back to that messy puzzle from the beginning and see how these rules bring some beautiful clarity.
Okay, watch how this all comes together. First, we bust open those parentheses using our master key, the distributive property. 3 times x is 3x, and 3 times 4 is 12. Next up, the commutative property lets us reorder the terms. Remember, that lets us change the order, so we can put the x's together. Then the associative property lets us change the grouping, so we can actually combine them. And what's the result? A much simpler 5x plus 12. See? Every single move we made had a reason, a rule behind it. So, okay, we solved one little algebra problem. Big deal, right? Well, yeah, it actually is a huge deal, because these aren't just little tricks for your algebra homework. They are the absolute bedrock of logical thinking, not just in math, but everywhere.
Think about it. Every complex equation you'll ever solve, every line of computer code that relies on logic, every single engineering formula that's used to build a bridge, they all depend on these fundamental properties being true and consistent every single time. Mastering them is the first real step to understanding the language of science and technology.
So we've seen how just a handful of simple, consistent rules can create this entire logical system for numbers. It kind of makes you wonder, right? What other complex systems in our world, maybe even in our own lives, could we finally understand if we just took the time to find their hidden rulebook?